Hello and welcome to MRCpsych on the Go Revision Essentials. My name is Dr. Alapasur and I'm a psychiatry trainee in the west of Scotland. Like many of you, I spent a lot of time commuting. This was valuable time that I could have spent revising for the MRCpsych examination. And so, I've started this podcast to help you revise on the go. Each episode breaks down one high-yield topic mapped to the syllabus. This is then followed by 5 questions to help reinforce your learning. So, grab your headphones, turn travel time into revision time, and let's get started. In episode 25, we explored emotion regulation and the role of the limbic system in emotional processing. In this episode, we begin a new series on stress. We start with the foundations, what stress actually is, and what it does to the body. One way to describe stress is a state of threatened homeostasis. This is the disruption of the body's internal equilibrium by external or internal demands. A stressor is any stimulus that threatens homeostasis. Stressors can be physical, such as injury or infection, or psychological, such as financial pressure, relationship breakdown, or bereavement. The stress response is the body's attempt to restore balance. Remember, stress refers to a state of threatened homeostasis. A stressor is any stimulus that disrupts internal equilibrium. The scientific study of stress was transformed by the work of Hans Selye, an Austrian-Canadian endocrinologist born in Vienna in 1907. Selye trained in medicine in Prague and later moved to Montreal, where he spent most of his career. His discovery of stress began in a way that is both scientifically important and, it has to be said, a little undignified. By his own admission, Selye was a clumsy laboratory technician. As a young researcher in the 1930s, he was attempting to identify a new sex hormone by injecting rats with ovarian extracts. The problem was that he kept dropping them, chasing them around the laboratory and handling them rather badly before managing to inject them. When he examined the rats, they had all developed the same triad of physical changes: enlarged adrenal glands, shrunken immune tissue, and gastric ulcers. Selye realised it was not the substance being injected that mattered. It was the non-specific demand placed on the body by any noxious stimulus, whether chemical or simply being manhandled by a clumsy researcher. He called this non-specific response stress and devoted the rest of his career to understanding it. He published his landmark paper in Nature in 1936 and later developed his findings into the General Adaptation Syndrome. Remember, Hans Selye described the body's non-specific response to any noxious demand, which he called stress. Selye proposed that the body responds to any stressor through a predictable 3-stage process, which he called the General Adaptation Syndrome. Stage 1 is the alarm stage. This is the immediate response to a stressor. The body perceives a threat and mobilises its resources through the sympathetic adrenal medullary system, or SAM. This triggers the classic fight-or-flight response within seconds. Heart rate and blood pressure increase. Adrenaline and noradrenaline are released from the adrenal medulla. Blood is diverted away from the gut and towards the muscles. Breathing quickens and pupils dilate. Selye noted that resistance to the stressor temporarily drops during the initial shock phase before recovering as the body mobilises. Stage 2 is the resistance stage. If the stressor persists, the body attempts to adapt. The SAM system is fast-acting, but not built for sustained demands. As the acute sympathetic response subsides, a slower, more sustained system takes over. The hypothalamic-pituitary-adrenal axis, or HPA axis. the hypothalamus releases corticotropin-releasing hormone. This stimulates the pituitary gland to release adrenocorticotropic hormone. This, in turn, stimulates the adrenal cortex to release cortisol. Cortisol is the primary stress hormone of the resistance stage. It mobilizes energy by raising blood glucose, suppresses immune function, and maintains cardiovascular tone. During this stage, the individual appears to cope, but physiological resources are being steadily depleted. Stage 3 is the exhaustion stage. If the stressor continues and the body's adaptive resources are exhausted, the individual enters the third stage. Cortisol levels remain chronically elevated, causing progressive damage to multiple organ systems. The consequences of chronic stress and HPA axis dysregulation include immunosuppression and increased susceptibility to infection, cardiovascular disease, metabolic disturbance, hippocampal atrophy, impaired memory and concentration, and an increased risk of depression and anxiety disorders. Remember, Selye's General Adaptation Syndrome describes 3 stages. The alarm stage, driven by the fast-acting sympathetic adrenal medullary system. The resistance stage, in which the slower hypothalamic-pituitary-adrenal axis takes over with cortisol as its primary hormone. And the exhaustion stage, in which prolonged stress leads to physiological damage. A useful mnemonic to remember the 3 stages is ARE. A for alarm, R for resistance, E for exhaustion. But what is the clinical significance of this in psychiatric practice? Chronic HPA axis. Dysregulation is one of the most consistently replicated biological findings in major depressive disorder. Elevated cortisol and failure to suppress cortisol on the dexamethasone suppression test have been documented in depression for decades. Cortisol is toxic to the CA1 pyramidal hippocampal neurons at high concentrations, and hippocampal volume reduction is seen in patients with chronic stress, PTSD, and recurrent depression. This may partly explain the cognitive difficulties, particularly memory impairment, seen in these conditions. Remember, chronic hypothalamic-pituitary-adrenal axis dysregulation and elevated cortisol are implicated in major depression, post-traumatic stress disorder, and cognitive impairment. Cortisol-mediated hippocampal atrophy may link prolonged stress to memory difficulties and increased psychiatric vulnerability. It is also important to distinguish between acute and chronic stress, as their physiological and psychological effects differ. Acute stress is short-lived and generally adaptive. The alarm response mobilizes the body efficiently, the stressor passes, and the system returns to baseline. In moderate amounts, acute stress can enhance performance and alertness. Chronic stress, by contrast, is prolonged and often insidious. It occurs when stressors persist over weeks, months, or years, such as in the context of poverty, relationship conflict, workplace pressure, or caring responsibilities. Chronic stress is associated with the exhaustion stage of Selye's model and with the greatest risk of physical and psychiatric harm. Now, let's test your recall. I will read out 5 exam-style questions. After each one, I will pause for 10 seconds so you can attempt them before hearing the answer. Question 1. A 45-year-old nurse presents with fatigue, recurrent infections, and low mood after caring for a critically ill relative for 8 months. Using Selye's model, which stage of the General Adaptation Syndrome best explains her presentation? the exhaustion stage. Prolonged stress has depleted her adaptive resources. Question 2. What are the 3 stages of Selye's General Adaptation Syndrome in order? The alarm stage, the resistance stage, and the exhaustion stage. A useful mnemonic is ARE. Question 3. Which hormone is the primary mediator of the resistance stage, and via which axis is it released? Cortisol, released via the hypothalamic-pituitary-adrenal axis. Question 4. A patient with a 10-year history of recurrent depression shows reduced hippocampal volume on MRI. What is the neurobiological mechanism linking chronic stress to this finding? Chronically elevated cortisol, resulting from HPA axis dysregulation, is neurotoxic to hippocampal neurons. Prolonged exposure leads to hippocampal atrophy, impairing memory and increasing vulnerability to further depressive episodes. Finally, question 5. What is the difference between a stressor and the stress response? A stressor is any stimulus that threatens homeostasis. The stress response is the body's physiological and psychological reaction aimed at restoring internal equilibrium. Let's summarise what we have learnt today. Hans Selye described the General Adaptation Syndrome, a 3-stage model comprising the alarm stage, the resistance stage, and the exhaustion stage. Remember this via the mnemonic ARE. The HPA axis and cortisol are central to the resistance stage. Chronic HPA dysregulation is implicated in depression, PTSD, and hippocampal atrophy. Acute stress is adaptive. Chronic stress depletes physiological resources and carries significant psychiatric and physical risk. In our next episode, we explore the social origins of stress, including life events, daily hassles, and the Holmes and Rahe Social Readjustment Rating Scale. Thank you very much for listening to this episode of MRCpsych on the Go Revision Essentials. I hope this episode helped to move your revision forward. If you have any questions or just want to continue the discussion, you can find me on LinkedIn at MRCpsych on the Go, spelled MRCPysch on the Go. This podcast is about making revision accessible. If you found it useful, liking and sharing it with others helps the goal more than anything else. That's it for today. I'm Dr. Alap Azurlikar, and as always, keep revising on the go.